Thank you very much for the invitation to come out here and speak. And this is such a wonderful conference room. It's almost in a way almost too nice, too comfortable. The lighting, the heat is just at the right temperature. I've been waking up at. I hurt my shoulder a couple weeks ago playing hockey. I didn't seem like it considered it was too bad, but I keep waking up at 4:30 in the morning because I sleep on my side. And so it could be like the combination of like medium-term sleep deprivation combined with this nice soft lighting and heat could induce me into like sleep at some point. So I hope what I said as a preface thing, like encourage your questions. As we're going. Feel free to interrupt if I want to keep going on, I'll let you know. But in particular, as I introduce like what I'm trying to do, I'm really going to foreground like a bigger picture, because I'm going to take the method and the theory that I'm using here and extend it, but also the particular statistical method I'm going to try to explain clearly, as my co-author has warned me that it's too complicated, nobody's ever going to use it. So let me know, like if at the point I'm going over and I put it near the front of the talk rather than at the end, as I'm going over it, if you want to talk about that, please let me know. So the title here, Stepping Stone versus Dead-End Jobs, is an attempt to think about how occupational structure affects the mobility, the intergenerational mobility of workers. And I'm going to use longitudinal data from the Survey of Income and Program Participation, SIPP, and the NLSY to look at the upward occupational mobility of low-wage workers. And the idea here begins with the notion of stepping stone jobs. The idea that there may be some jobs, some low-wage jobs, that although they pay low wages, by definition, they promote the acquisition of skills that enhance subsequent upward mobility. So the idea would be that working, like for many, it could be that for low-wage jobs in general, if they're dead-end jobs, that working in them, other than the fact that you're working, as sort of a reflection of like fundamental changes in our welfare policy, pushing people into work. I mean, you're working, but it could be like in a dead-end job, it doesn't lead anywhere. That the accumulation of work experience doesn't result in the accumulation of human capital that leads to subsequent upward mobility. If that's the case, if the dead-end perspective is the case, then when you look at mobility tables, what's going on is that workers are perhaps sorting based on sort of intrinsic or unobserved measures of their ability. The alternative argument is that in a stepping stone environment, in a stepping stone job, the work experience in that low-wage job is actually productive, actually beneficial, leads to skill acquisition, and leads to subsequent upward mobility. What I'm pulling in here, a combination of like two different theories. One is the career lines literature in sociology, which sort of has a long tradition going back to Stillerman in the late 1970s, but then sort of like died out, partly because of its descriptive complexity. So the career lines literature looks at patterns of detailed occupational mobility, not between large categories, between detailed 3-digit occupations, and looks to try to find like institutional structures of occupational mobility. But partly because you just get overwhelmed with how much descriptive information you have, I think it sort of reached a dead end. I'm trying to resurrect this literature in a theoretical way, combined with the recent literature over the past decade or so on occupation-specific human capital and task-specific human capital coming from economics, where the idea is that human capital is not just a general characteristic, but it's specific to the accumulation of very heterogeneous skills that inhere in occupations and actually help us explain the very non-random pattern of mobility between like detailed 3-digit occupations. The model that I'm using, which is really just it's a conditional logic model, but the goal is to take the occupational structure into account. So that's not only like the occupation that someone is in and the occupation they move to, but the broad set of like alternative occupations they could have moved to, in a combination of both destination occupation characteristics and interaction terms between individual characteristics and potential destination occupations. But just to back up for a second here, which is sort of my broader interest in this topic, is like to think about intra-generational mobility. And what I argue is that this is first like a central issue in sociology dating all the way back to Lipset and Bendix, in 1959. Furthermore, that we have lots of evidence. Like if you look at mobility tables, intergenerational mobility tables, we have lots of evidence, despite like the tendency of the process for social reproduction or people to stay like in the original occupational class, we have plenty of evidence that there is quite a bit of mobility. And I just feel like that mobility itself, and what I mean there is not just the average returns in a human capital model, but the larger, like discrete jumps up quintiles or deciles of a mobility table are sort of like under-theorized. And so I think it's sort of, for somebody who studies intragenerational mobility, it's sort of like a black box. Why does mobility occur? What are the competing theories that would explain why somebody jumps up like a decile or quintile on a mobility matrix? So now I'm going to like momentarily jump into the method here. And part of this is to think about how what I'm doing both applies to other processes, both in terms of intergenerational mobility in general, and thinking about careers and how we would model careers, but also other types of demographic data. And I'm thinking, like in particular, migration models, where rather than just trying to model did you migrate or what region of the country you migrated to, like a migration data set with very, very specific choice categories. So not only state, what if you modeled all the way down to like county or tract? My next project, which builds on the methods of this research, is going to use restricted access ACS data and SIPP data, where I'm going to take advantage of essentially the one-year longitudinal panel that the ACS represents to look at migration. But with the restricted access data, I'll have detailed geographic codes like on the census tract that people move to, and at least theoretically, the census tract that they move from. And so that creates a choice model where the sheer number of choices, in terms of thinking about like a conditional logit framework, the sheer numbers of choices like is so large that you really, like a multinomial logit model where you have a separate outcome for each choice just doesn't work, and you have to go to sort of a conditional logit framework where you can sample from the alternative choices. Now, a critique of the basic conditional logit approach is that, okay, well, what about the IIA assumption, which is the assumption that the error terms are independent across the choices for a particular individual? One of the latent class module, like the latent class conditional logit, like its sibling, the mixed logit model, allows the parameters to vary, the coefficients to vary across individuals. The latent class logit in particular allows for sampling of alternatives within the latent classes, and so it's like really the only feasible model for this, I think, really relevant demographic type of data set where you have longitudinal data either on occupational mobility with lots of detail on 3-digit occupations, and you don't want to collapse it into a small number of aggregate categories, or migration, where you're talking about not migration to a region, which we've done with the multinomial logit, but migration to census tracts or migration to counties, and you want detailed contextual data from those counties as part of the explanatory variable process. That's the interaction of the latent class logit model. I'm going to present some of these models to allow the relaxation of the IIA assumption. Although the reviewers for this paper at AGS really did not like these models, so I've unfortunately put them in appendix, despite the fact I spent a lot of time writing a data routine to do this analysis. But I'll come back and talk more about these later, because I think this kind of choice modeling is the future. And I think it's potentially really advantageous. Also, in addition, it allows for the expression of heterogeneity in the coefficients across categories. And so in particular, for my model, when I run these latent class conditional logit models, I can let the effect of your occupation, the occupation you're in, vary. And that, in certain theoretical situations, that turns out to be quite interesting. And so I'm extending this to talk about a multinomial conditional logit model, MCL. And in sociology, these first appear in Breen in 1994. And it's a way of like adding covariates to a contingency table, like to a table of a social mobility matrix. Now, these were used to be done with like log linear models. The problem is it's really difficult to add in individual level explanatory variables. But you can generalize like the log linear approach to a multinomial conditional logit where you have characteristics of the origin and destination occupations, and characteristics of the individuals. In particular, though, I'm going to complicate it a little bit further, because what I want to do is study like wage mobility as like the dependent variable, but where it's wage mobility as like a discrete jump across a certain threshold. In particular, for my particular topic today, it's like movement out of low wages, which I'm going to variously define as earning $4 more than when you started the sample, or above like a $14 an hour threshold or a $16 an hour threshold. So it's above a certain threshold. That's the multinomial part of the model. So I'm going to have an outcome which is 1 will be staying in low wages, 2 will be getting out of low wages in your initial occupation, and 3 is going to be getting out of low wages in a different occupation. So that's the multinomial part. But the conditional logit part is occupational mobility. And what I want to do is use all of the 490 three-digit occupations to model which specific occupation my respondents, the workers in my sample, move to if they move up. And so here, the dependent variables occupation in all occupations are potential choices. Now, the equivalent from like a migration model would be, here's where you move to, but we want characteristics of the places you didn't move to as well to try to explain why you moved to where you did. The sheer amount of data, like even in this, what starts out as a relatively small sample, so I've got 18, I'm combining, in the SIPP analysis, I'm combining 4 waves of SIPP data. And the longer this paper, unfortunately, has taken, the more SIPP data like I've accumulated. So there are a number of reasons why I really need to finish it like right now. But one is like just data analysis exhaustion. But I end up with 18,700 workers who start in low wages at the beginning of the SIPP, of the respective SIPP panel. And I've got up to 12 waves of data, and for each wave, I want to model all possible occupations that they can move to. So that's just too much data, even for the Unix computers to handle. And so you need to sample. And so one of the benefits of the conditional logit approach and the MCL version of the conditional logit and the latent class conditional logit is it lets you sample from the alternatives. And so what I'm going to do is to reduce the size of the data analysis. I'm going to take a random sample. Well, first I'm going to take if you move, what occupation you move to. And then the characteristic property of the conditional logit is that you can sample randomly from the alternatives. So then I'm going to take a sample of 20 of the unchosen occupational alternatives that you could have gone to, and then run the model. And then
Do you restrict it only to people who are continuously employed?
No, they can go in and out. So that'll be clear when I look at the table, sort of where what happens with the sample. So I start with people who are employed because of a question asked in the first wave about how long they've been in this specific occupation. But then they stay, I stick with that group, and if you drop out momentarily and come back in, then you're part of the sample. And I've done multinomial logit models where I'm also trying to model so what affects like dropping out of employment as well. And I just want to put this in parentheses here. So I just did an annual review article on intragenerational mobility, which was very painful to do in some ways, but also really beneficial in that I had to read everything that's recently been done in sociology and much of economics, sort of in intergenerational mobility. And what's popping up clearly is that there's an increased interest in sequence analysis to study careers. And I think that's, like, thematically or substantively, that definitely relates to what I'm doing here. And I think it gets back to the earlier literature in sociology and career lines coming from, like, Spillerman's article in 1977. However, like in practice, if you look at what comes out of a sequence analysis, it ends up, even if you start with your units of analysis being, like, detailed occupations, what comes out is often highly aggregated. And I think it ultimately misses, it's sort of the same problem that the career lines literature had. It comes out with too much information to make sense of it. You have to aggregate the career categories into like 1 of 7 or so different possibilities. Furthermore, it really doesn't let you test like conditional probabilities. You're essentially getting patterns that are large patterns, but not conditional on sets of covariates. And I think that's sort of problematic, but I'd be happy to talk more about that, the difference later. Okay, so here's an example, and this is where this huge screen is really beneficial. But I just want to see if I can express like what's going on with my data structure here. So first, table 1A, is an example of data structure for a multinomial logit model. And it's just one person here through the whole thing. So one person, individual ID 1. The dependent variable is either stay in low wages, upward mobility, same occupation, or upward mobility for different occupations. So this person is changing occupations and experiencing upward mobility. And the covariate here, just very simple example, the covariate is gender, and so we're talking about a woman. Now this will be all the data you need to run like a multinomial logit of occupational mobility, taking gender into account. You can express this in a conditional logit framework, and that's in table 1B. So any multinomial logit model can be expressed in a conditional logit framework. You just need one case per person per outcome category. And so that's why we go from 1 row to 3 rows, where now we still have the same person. So the individual ID is 1. We have a variable for saying, was this the choice, or was this the choice that they ended up in, the outcome they ended up in? And then dummy variables indicating, so in this case, there's a dummy variable for choice 2, interact with the constant and the individual variable gender, and a dummy variable for choice 3, which is upward mobility to a different occupation, interacted with the constant term and interacted with any individual independent variable. So this is routine, this going from 1A to 1B. Now what I'm doing in the paper is 1C, where I'm taking this multinomial part expressed in a conditional logit, and then expanding, so the final 4 rows here, 3, 4, 5, and 6, are expanding the outcome, the number of choices for somebody who moves to a different occupation, to actually be those occupations that they either moved to or could have moved to. So now we've gone from 3 lines, this is the multinomial version, to this is the multinomial conditional logit version, which has both an individual variable gender interacted with outcome 2 and outcome 3, the dummy variable, and 4 new lines, which are representative here of the type of gender-specific occupation. So that's the variable here, percent female, proportion female, 0.2, 0.4, 0.6, and 0.8. And now we can interact. In this model, we have coefficients both for gender, so an effective gender on upward mobility, but by interacting gender with the gender composition, we're incorporating the well-known fact that there's like occupational segregation and sorting in the process of upward mobility. So women will be more likely to move to higher gender-specific occupations. Now, you could do this analysis like in a multinomial logit framework by having separate destination categories for each one of these outcomes. But that gets more problematic when you want to do all occupations, because then you'd be running a multinomial logit with 490 separate, outcome categories. So this may seem like counterintuitive, but what's fascinating here is that if these processes are independent, like the probability of upward mobility and the probability of occupational choice, if they're independent, you get exactly the same results back running this model as you do running 1B and 1A. Like the effective gender is exactly the same. And I know because I've simulated the data and run it just because I know I have to convince the reviewers it's the case. But I would argue the reality is this is what workers are actually facing. Like they're not applying for a job which says upward mobility, they're applying to a job in a specific occupation. And if we want to take into account the role that occupational structure plays, so for instance, an expansion or decline of occupations in a specific category. So what happens in a context where occupations that are heavily female expand? That increases essentially the opportunity for women to move upwardly into those occupations. To have that kind of model, I think you need to move to this kind of multinomial conditional logit framework. And it's not just, and these things interact with each other. So in other words, somebody who doesn't move up, it could be because of their individual characteristics, but it could also be because of structural changes. So like if there's a contraction in job opportunities in the occupations that they qualify for, that's the reason that they're not moving up, not their individual characteristics, or it's like the interaction between the two. And this kind of model gives you the flexibility to do that. So the dependent variable I'm working with here is, did the worker experience upward mobility defined as a $4 increase above where they started, or defined as reaching a threshold? So I'm starting with workers who are earning less than $11 per hour in 2011, and one dependent variable is, do they earn above $14 an hour? Or do they earn $4 more than where they started? The explanatory variable is going to be individual characteristics, in other words, such as race, gender, human capital, occupational characteristics, structural factors related to the potential destination occupations, and interaction terms between individual characteristics, such as how long you've been working in this particular occupation, and how well did those skills in that occupation, say you're working as a cashier, what's the probability you're going to move to be like a food service manager? What's the rate of skill transfer between that particular occupation, cashier, and a potential destination occupation, food service manager? Okay, so I talked about the parallels. I think there are parallels here in like in migration research. But it's not, the problem, for instance, if you looked at like a social network approach to migration, you look at consistent flows between one part of the country, one detailed part of the country and the other, I think you're picking up, well, certainly preferences, but you're also picking up social network connections. Now, if that particular destination is booming, then you've got an interaction term between individual characteristics like social network connections to a particular destination and expansion or contraction of job opportunities in that destination. And I think that calls for a similar type of model, which is the interaction between individual characteristics and the characteristics of potential destinations. Yes?
Could you go back to the slide? So your choice set is unclear to me. So it's not a multiplication of 3y with all occupations.
Right.
You only consider differentiations by occupation for upper mobility.
Right. Mm-hmm. No, there are a couple ways to do it. So first, the easiest way is to say, I want to model, I want everybody in the model. I don't want to just isolate the people who move upwardly, because then you've already lost. The part of what I want to explain is, if you don't move, that's a reflection of lack of opportunity, potentially in occupations that are destination occupations for your specific origin occupation. Now, so what I'm doing is taking the third outcome and expanding it. Now, I also estimate models of lateral mobility, where I'm looking not only at, so right now you're a 1 if you experience continued low wages, but there's a similar process of occupational mobility for people who are moving laterally, and you can do that as well. So in this case, another multiplication is staying in low wages but moving to another low wage occupation, and I can model that as well. The process in terms of the returns to occupational skill transfers are very similar. So the point here is like flexibility, and it turns out that these characteristics, the interaction of gender, so the interaction of gender by D3, which is the third upward mobility, or the interaction of gender by D2, which is upward mobility in the same occupation, if there's no effect of destination occupation characteristics, those are constant. Like those aren't affected. The expansion or contraction, the number of categories I'm adding here, gets absorbed in the constant term. So the constant term definitely changes, but the interaction with individual characteristics don't. And the key thing is that they are interacted with the dummy variable representing this specific outcome, like multinomial outcome category. Now, that's the funny thing is I backed into doing this model. I didn't have a name for it last time. Now I found out there's actually this legacy of this particular MCL model, both in economics and sociology, dating back to the 1990s. But it sort of stops like in the mid-2000s. I think partially sort of in want of an application. Okay, structural variables. So the goal of this model is a flexible approach that can incorporate needed aspects of the real conditions that workers face when they're thinking about occupational mobility. And so that's in the potential destination occupations. I want to know, first, how big is that occupation? Has that occupation been growing? And so I'm getting that for the recent data I'm getting that from ACS, like yearly ACS data. So I get a yearly snapshot of growth in detailed occupations. And entry portals turn out to be very significant empirically. And what I mean by there is, like, what occupations are entry points for low-wage workers? And so I take CPS mobility data and look at workers from low-wage occupations, and if they move up, where are they going? What that identifies is a set of jobs that are not necessarily, they're characterized as like soft landing points, so points of entry for low-wage workers who are taking advantage of potential upward mobility opportunities. Secondly, I'm looking at a series of interaction terms between occupational structure and individual variables, and that's the benefit of this MCL approach, is it lets you look at the interaction of structure and individual characteristics. One of them, obviously, is like gender and race interacted with the characteristic of destination occupations, and this should be pretty like evident to anybody in like social stratification. Clearly, like the flow of workers across like the genderedness of occupations is what reproduces that characteristic. So we take that into account. But then, relevant to the theory of this paper, identifying mobility pathways or skill transferability between occupations. So a worker in origin occupation A, of which there are 490, and a potential destination occupation B. What's the skill overlap between those two occupations? And that's really just, in some ways, it's sort of common sense. But the mobility between occupations is affected, or should be affected, by the degree to which like your skills that are accumulated over time are transferable. So like we see mobility between like lawyers and judges, not lawyers to podiatrists. Like they have a similar level of education, and so like an abstract notion of human capital says, okay, those are similar, but you look at the mobility data, you won't see, unless it's really unusual, like in the CPS data, you just won't see mobility between lawyers and podiatrists. And that tells you something about the specific heterogeneous nature of skills, tasks, specific and occupational specific human capital. And that specificity, that very non-random nature of occupational mobility, is what I want to take into account in the model. And so this gets back to sort of what I talked about earlier, like sociological literature on like what do we mean by a career? And so to measure the skill similarity, I'm looking at data from two data sets. First, the ONET, which is the successor to the Dictionary of Occupational Titles, has tons and tons of variables about skill dimensions and how important they are. And the other is the CPS, which is a different approach, where I'm looking at the actual flow of people between occupations, and I'm getting a measure of how unusual that flow is. Now, it turns out, although these are sort of similar ideas, they turn out to be a little bit different, and it's sort of interesting. What I'm going to argue is that the CPS is actually better at getting at the institutional framework of mobility between occupations, because there's some cases where the ONET, what the ONET is doing is breaking down it, like, it's sort of missing the forest for the trees. It's breaking down an occupation into like 150 characteristics. And then these really experienced raters rate every single one of these characteristics, like arm flexibility, eyesight. They rate how important those skills are. And what I've done is looked at the correlation among all of those variables between pairs of occupations. What's fascinating, though, is it misses. Like these are things that show up as differences between my CPS measure of mobility, which is based on mobility, relative mobility flows, and the ONET, which is based on these skill dimensions, lots and lots of skill dimensions. Is that sometimes the ONET just misses things, like taxi drivers and chauffeurs to dispatchers is a high rate of mobility, which makes sense in the CPS, because that's the next step up. If you're in, well, not that when the taxi cabs are disappearing rapidly, but when this data existed, that's the next step up in a career. Become a dispatcher. But if you break it down into the essential skills, the ONET had no, like there was actually a negative correlation. I've said anything with a negative correlation is zero. Like there's no skill overlap between those two occupations. Similarly, you can find ones where the ONET, breaking it, this is this column right here, the ONET, if you break it down into its constituent skills, the ONET says, these are really a good match. But then you look at it as a human being, and you're like, these don't, it makes sense, there's no mobility. So a dishwasher to a construction trade helper. In the CPS, it's zero. There's no observed mobility in the 20 years of CPS data I have between those two detailed occupations, whereas the ONET says they should be really similar. And I think that that's a consequence of like missing the global aspects of how mobility happens by only looking at really because even the tiniest skill dimension is going to miss aspects of why the skill of a dishwasher is different than the skill of a construction helper. Anyway, that's my take on it. So I'm going to have to fast forward a little bit here. Usually my strategy is to talk fast when I've already been doing that. What I'm going to propose, so I want to differentiate between two theories of dead-end and stepping stone jobs. One is pessimistic. That's the dead-end perspective. That just says mobility is explained by sorting on unobserved human capital, which might be like intelligence or ambition, and the people who move up were just destined to move up. The people who get left behind are going to be negatively selected on those unobserved characteristics. That's the dead-end perspective. I'm not advocating, like, I'm not saying that I wish that were true. However, empirically, there's evidence for it. So that's the negative perspective. So low pay, no increases in skills that promote mobility. The alternative is the idea of a stepping stone, which is that the accumulation of experience in your specific detailed occupation will promote, not general mobility, but promote mobility to a very specific set of occupations that are linked to that occupation because of skill overlap or because of some sort of occupational pathway which may be partly institutional. And I'm going to look at an interaction term. When I jump to my models, it's like I'm going to look at an interaction term between the skill transfer and occupation-specific experience. And like key tests will be, is that interaction term between the connectedness of the occupation and your experience in your origin occupation, is that interaction term significant? That's the key theoretical test. Okay, the SIPP data is great in a lot of ways. I've got lots and lots of cases, at least to start with. The one problem is that the question on how long have you been in that occupation is retrospective. They just ask it in the first wave. How long have you been working in this line of work or occupation? Because I got pushback on that. Like, I think measurement error, there is measurement error in that. Measurement error is going to tend to push my results towards 0. But because I got pushback on it, I also went and estimated the same model with NLSY data, which is advantageous because you have the whole career history. Just have fewer cases. Okay, I'm going to jump ahead to the second time, but I can come back to this stuff later. Well, that's not the end of the talk. I'm going to my PDFs, which are intimidatingly long. I think that's still partially readable. Okay, so here's the data I have for the SIPP. So it's a combination of 4 different waves. I start off with workers who are earning low wages in wave 1, and as a measurement to reduce the level of measurement error, I'm restricting it to people who also earn low wages in the second wave. So to try to get out of like spurious mobility just because of misreporting of wages. And then this is sort of like a demographic life table. What I'm looking for is like people who are exiting this table for a variety of reasons. Now, it could be, like in column 1, the end of the panel. It could be attrition. Somebody who attrits from the data for some reason I can't explain and it just doesn't come back. These are people who are temporarily absent, but then return to the data. These are people who are out of the labor force. So they're still contributing cases while they're in the data. And these people can come back into the data. Now, this is the sample of people who are currently earning low wages, and then you can experience upward mobility in 2 ways. Either upward mobility in the same occupation. And one of the surprising things, like these are low-wage jobs. Even with cashiers, which is like in a way sort of like the paradigmatic expression of a dead-end job, there's a lot of mobility within the occupation above like these thresholds of gaining $4 an hour or going above $14 an hour. the final category, category 7, is upward mobility to a different occupation. So at the end of the sample, I started with 18,700. I've got 1,494 that experience upward mobility in the same occupation and 1,958 that are moving to a different occupation. So like right on the surface, you can see, like, is this optimistic or pessimistic? It's over, potentially over a 3 or 4 year period, given the short panel in SIPP. Most of these workers continue to be either in low wages or out of the labor force. And what we're really modeling here is, this group of 1,900. You can be pessimistic, and it's true, like the glass is definitely half full here. But there is mobility. And the question is, how do we explain that mobility, and to what degree might this, like, stepping stone perspective, which is an optimistic perspective of skill accumulation within your occupation, to what degree might this be part of the explanation here? And I've got alternative ways to define the dependent variable, so I can look at it across different thresholds. I can look at it as like average occupational wages, et cetera. And you get similar results. These are the explanatory variables. I just want to focus on,
Question.
yes.
So I think this idea about mobility within occupations is really appealing to me. But you're attributing that mostly to skill improvement. Could it also be a network effect, ties?
Yeah, and that's why I think that one of the reasons why like the CPS data is better is think about the transition like from taxi drivers to dispatchers. Part of it is picking up like a network effect. Like you're working the same. In one way to like reconceptualize skills is both like skills like driving a taxi, but it's also skills in terms of like ferreting out information about job opportunities, being in the right place at the right time when that job as a dispatcher opens up. Even working in the same firm next to people who are working as dispatchers. There's like a diffusion of knowledge, I would argue. Now, you could say, well, okay, it's partly like the institutional framework of how jobs are structured. That's partly what's coming out here. So to call it purely skill might be stretching it. I guess it's like the way in which occupational structure provides mobility pathways between 3-digit occupations, which partly reflects occupational institutional structure and partly reflects skills, I guess. So I've got a lot of like the key independent variable from the individual perspective is the log months of experience in the current occupations. That's the length of time you've been working in that low wage occupation. Key structural variables, and this in a broader sense in terms of like why you might want to run this kind of model in general, is I can take into account very detailed characteristics, not of just the occupation you're in, but the occupation you could move to. So occupational size, is it how much high wage occupational employment growth has been going on in that occupation? Is it an entry portal? And again, that's taking advantage of looking at the CPS data to see what occupations are receiving low wage workers. Unionization, white and gender, demographic composition, whether it's a high wage destination occupation, and then like testing model of secondary labor markets by looking at like, can a simple model of occupational structure where we're defining like a interior and exterior sector, can that explain away like what I'm finding here? This is the same thing for the NLSY data. Let's skip over. Okay, so this is the simple approach to what I'm doing, which is just run a multinomial logic. And what I hope to do here is both like explain like what the baseline is if you were to run a multinomial logic where you're looking at, with the default categories you stayed in low wages. And the alternative categories in the multinomial framework is upward mobility in the same occupation, right here, or upward mobility in a different occupation. And the key question is, what are the returns to experience? Now, in the same occupation, it turns out that the longer, which sort of makes sense, the longer you've been working as a cashier, the more likely you are to experience upward mobility as a cashier. Although it is interesting, like to what degree this actually happens and how strong this effect actually is. The third category is upward mobility to a different occupation. And this effect is negative. what that says empirically, even though I wish it were not the case, it says the longer you've been working as a cashier, the less likely you are to move up. And that's consistent, well, it's consistent with a couple of different hypotheses, but it's definitely consistent with this idea of negative, like of a dead-end job, and the lack of any beneficial skill accumulation in that job. So the people who move up are just different. Like, think about waiters and waitresses. Lots of people work as waiters and waitresses during college. Now, if you were just to look at how much mobility is there out of being a waiter or a waitress, you'd find lots of mobility. But I would argue it's not necessarily anything about that occupation. It's just about the characteristics of people who are temporarily in that occupation in the terms of a life course, and then they're moving up. And what you'd probably find is that the longer you work as a waiter or waitress, given that kind of sorting, the less likely you are to move up. So this is an argument about unobserved heterogeneity. And unobserved heterogeneity causing a downward bias in the effective occupational experience. And this is a pessimistic effect in the way I'm looking at it, because it suggests increasing negative sorting and increasing lack of opportunities for people who spend time in low-wage jobs. Yes?
Ted, would you say that's even an underestimate of a negative effect, given that you don't have that third possibility modeled of changing occupation in same or lower wages, so that you actually, the people who are really adversely selected, which are changing their, from cashier to some other dead-end job.
No, you're exactly right. That intuition is really good. And so when I did this model, I was forced to, because of reviewer, I did a lateral mobility in addition to upward that pulls out people who are like leaving the occupation but still staying at low wages, and the effect is even greater. Like what's left over here, or even more negative. So like this is the baseline. But I just want to draw you, so I want to focus one's attention on this negative effect, which I think is consistent with a dead-end perspective, which is sort of what I want to argue against. So these are the multinomial, these are the MCL models, so multinomial conditional logic models. And each one of these is so each column is a different like articulation of it, and there are lots of explanatory variables. So the key ones are highlighted. So the first one here in row 2, this is the same. This is the raw effective experience, and you see that this is negative. So as your experience goes up, you're less likely to be upward mobility, to experience upward mobility to a different occupation. And that's consistent with the dead-end perspective. But it's this interaction term here in row 1, which is the interaction. Well, first there's a dummy variable indicating this is outcome category 3, by going back all the way back to table 1. And then there's the occupational similarity, which is my measure of how like connected these 3-digit occupations are. And again, that's from either the CPS data or the ONET data. Like, is a cashier, like taxi dispatcher, but taxi driver to taxi dispatcher, electrician apprentice to electrician, occupations that have a high degree of overlap. And that's interacted or multiplied with your accumulated occupational experience. And that's an expression of this like stepping stone effect. And so here, you can't, like to go back to this previous model, this is a simpler model to do, but you can't estimate this stepping stone effect in that model, because it's something about the interaction between an individual characteristic, an occupational characteristic, the origin and destination skill transferability, and an individual characteristic, which is your accumulated experience. And the only way to do that is in this kind of flexible multinomial conditional logic framework. And the exciting thing is that so what I'm looking for is that these positive coefficients for this interaction term are positive and significant across the different like versions or flavors of this particular type of model. And then the other thing, these are all the structural characteristics. So potential destination occupation. So for instance, what really turns out to be significant is this variable on whether the destination occupation is like an entry portal. Like, does it receive large numbers of low-wage workers in the CPS data? And that turns out to overwhelm the effective size, which actually turns out to be insignificant or negative. But you definitely see like these terms relating to gender composition of the occupation. And I think that's where like somebody studying occupational gender segregation could use this kind of model to incorporate both individual level models and more complex, it's not just the gender composition, but it's the gender composition in the context of other occupation level characteristics, which would make this an interesting model to look at. So here, just looking across the different columns here, so this is the model with the CPS data with the relative wage mobility up to $4 an hour. This is the ONET version, which in general never fits quite as well. And my argument for this is that ONET's picking up something a little bit different, and sometimes it's missing occupations that are really related in terms of mobility flows. This is across a $14 threshold, a $16 threshold for defining upward mobility. So the 16, and that's potentially a big jump. Like the median, this is 2011, so we're looking across the median wage or so in 2011, and you still see the same effect. If you define things in terms of not your wages, but the average occupational wages, you still, I don't think that's as good, but you still get a similar outcome. This is the model of upward and lateral mobility. So I'm breaking out, it shows like the potential flexibility of the approach. So I'm looking at not only upward mobility to a different occupation, but lateral mobility, still low wages to a different occupation. Like Dalton anticipated, you see that this effect actually got more negative when I broke those workers out. And this is the best fitting latent class conditional logic model. And like I said, the amount of time I spent programming this versus the amount of reviewers at AGS hated it. It's really frustrating, so I'm persisting in keeping it in the model. Because I do think it's like the future of these choice models. Like if you take seriously the IAA problem, to respond to it, you need to think about what happens when we don't assume that the error term is independent across the different occupations. So something that affects your choice to become a cashier also affects your choice of becoming a similar, janitor or something. You can relax that, but this is the best fitting one. There were two classes, and you see what it does is expresses heterogeneity in this key independent variable. So I think that's consistent with the idea that some jobs, some occupations are stepping stones and some aren't. I think that's like a fruitful way to think about how this kind of choice modeling framework can, almost like a multi-level model, can let you look at variation in the coefficients across, in this case, across the categories of occupations. And then this was like maybe overkill, but I thought of like all sorts of other potential exceptions. So you can run it with, what I've done in all the models is added in controls for the origin occupational category. So I'm allowing for differences in the rate of mobility based on what occupation you're in. And I can take those out or add them into the 3-digit level, and it doesn't affect the results. So I can look at only men. I can exclude managers, supervisors, and apprentices. And theoretically interesting, I can look only at workers coming from like secondary labor, like particular definitions. One of the hard things of the secondary labor market perspective is it's sort of slippery. Like, how do you define it? Is there a good theoretical way to define it? I can define it like multiple ways, and I seem to get a pretty consistent set of findings, although eventually the sample size becomes challenging. Anyway, I hope to have at least done a good job articulating why the theory, in this case, thinking about careers, and that's more than just thinking about low-wage workers. And low-wage workers still have careers. I don't think we want to define careers as only something like middle-class workers have. But thinking about careers as sequences of occupations, and that's the affinity with sequence analysis. But thinking about it in a way that allows us to think about conditional probabilities. Like, how does your career unfold, rather than looking at it only like whole career data. But also why this kind of models, statistical models, is of potential interest. So I'll stop here with hopefully some time for questions.